Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2018 Process Instrumentation, Dynamics and Control. GATE 2018 question paper and the answer key link is available in my description box. You can download it. Question number 45. For a closed loop system, consider the following transfer function: process transfer function GP of S, controller transfer function GC of S, measuring device transfer function GM of S, and final control element GF of S. So GP of S 2 by 7S plus 1, GC of S 2, GM of S 1, and GF of S is equal to 1. The offset in the closed loop response due to a unit step change introduced in the set point of the output variable. Objective of this problem: to determine the offset in the closed loop response due to a unit step change introduced in the set point. So R of t is equal to 1. What is R here? R is a set point. So the unit step change introduced in the set point of the output variable. Data unit step change in the set point, that is SP set point or capital R. So GP of S process transfer function, this is given data 2 by 7S plus 1. Controller transfer function GC of S 2. Measuring device transfer function GM of S 1. Final control element transfer function GF of S is equal to 1. Determination part to determine the offset value. So solution: closed loop response or feedback control system. R is a set point, B is a measuring element, so E is a error. So here GC of S controller transfer function, P is a controller output or pneumatic signal. So GF of S final control element transfer function, capital M manipulated variable, capital U disturbance, GP of S process transfer function, C controller variable or output, GM of S that is measuring device transfer function. So here the plus minus indicate negative feedback control system. Unit step change introduced in the set point. The meaning of this: we should take R of t is equal to 1. So for this problem comes under servo mechanism. So the set point change, that's why this problem comes under servo mechanism. So this is negative feedback control system. So negative feedback servo mechanism. Okay. We want R of S. What do you do here? They'll take Laplace transform. R of S is equal to 1 by S. This is equation number 1. So already I said this is negative feedback servo mechanism. Servo mechanism means we should take C of S by R of S. Why? Because set point change. So what is the formula here? C of S by R of S is equal to product of transfer function between C and S, C and R is right, divided by 1 plus product of transfer function in entire loop. So here C of S by R of S is equal to product of transfer function between C and R. What is the meaning here? C and R mean the product of transfer function GC of S, GF of S into GP of S. This is the numerator part. Okay. So the product of transfer function between C and R divided by 1 plus product of transfer function in entire loop. Entire loop mean we should take all these transfer function product value. GC of s, GF of s, GP of s and GM of s. This is the multiplication here. 1 plus GC of s, GF of s, GP of s into GM of s. Okay. So this is servo mechanism, negative feedback control system. So here we know GC of s, GF of s, GP of s and GM of s. Substitute the value here. So the 2 into 1 into 2 divided by 7s plus 1 divided by 1 plus 2 2s are 4, 4 divided by 7s plus 1. So the finally C of s by R of s is equal to 4 divided by 7s plus 1 in the numerator part, whole divided by 1 plus 4 by 7s plus 1. Okay. So already we know R of s is right. The problem itself, the set point change is right. So the unit set point. So here R of t is equal to 1 mean R of s is equal to 1 by s. So we know the R of s value. So refer the equation 1. Substitute equation 1 in equation 2. So what is the C of s here? 4 by 7s plus 1 divided by s into 1 plus 4 by 7s plus 1. So here 4 by 7s plus 1 whole divided by s into, take LCM here, 7s plus 1 plus 4 by 7s plus 1. Simplify this expression, numerator term 4 by 7s plus 1 divided by s into numerator part 7s plus 5 by 7s plus 1 is right. So here C of s is equal to 4 by 7s plus 1 into s into 7s plus 5 divided by 7s plus 1. So these two terms are cancelled. Finally we get 4 by s into 7s plus 5. So this is not the correct form. Okay. So what do you do here? Take 5 outside. 4 divided by s into 5 into 7 by 5 s plus 1. So here the numerator part term, the 4 by 5. This 5 goes to numerator side. 4 by 5 divided by s into 7 by 5 s plus 1. This is equation number 3. So objective of this problem, the offset. Determine the offset value. Offset is equal to R of infinity minus C of infinity. This is equation number 4. So we want R of infinity and C of infinity. So after calculating these two, substitute here, find out the offset value. So here we want C of infinity first. What do you do here? We know that final value theorem. So final value theorem, limit of t tending to infinity, C of t is equal to limit of s tending to 0, s into C of s. This is equation number 5. So here we want C of s value. Already we have C of s. Refer equation number 3 here. Yeah. So C of s equation. This C of s value substitute in that expression. 4 by 5 divided by s into 7 by 5 s plus 1. Substitute here. Substitute equation 3 in equation 5. So here what do you do? Limit t tending to infinity, C of t is equal to limit s tending to 0, s into, substitute this value 4 by 5 divided by s into 7 by 5 s plus 1. Here s's are cancelled is right. So here in left hand side t tending to infinity, that's why C of infinity. Right hand side substitute s tending to 0. S tending to 0 means this part is 0 is right. 7 by 5 into 0, 0, 0 plus 1, that is 1 is right. For numerator part 4 by 5. So finally C of infinity is equal to 4 by 5 or 0.8. Are you clear? Okay. So next one is R of infinity. So we know that unit step change in set point. So we should take R of t is equal to 1. T tending to infinity mean what about the R of infinity? R of infinity also 1. Now we have R of infinity 1, C of infinity. So we know the formula offset. Offset is equal to C of infinity minus R of infinity. Is that right? R of infinity minus C of infinity. Is it correct? So R of infinity minus C of infinity here. R of infinity we know is right. R of infinity values are 1, C of infinity value is 0.8. Substitute C of infinity and R of infinity in equation 4 is right. Equation 4, I think this expression offset is equal to R of infinity minus C of infinity. Substitute here, find out the offset value. Offset is equal to 0.2. So this is the answer for this problem. Okay, so the offset formula R of infinity minus C of infinity. So for further related videos, you can like, share and subscribe my channel. Thank you.